Hi, I'm Adam from Confluent. In this module, we're going to be talking about modeling as facts versus delta event types. A fact event details the entire scope of what happened at a specific point in time. It contains all of the fields and values necessary to completely describe the fact in the context of your business. You can also think of a fact event similar to how you may think of a row in a database, a complete set of data pertaining to that row at that point in time. The cart event on one side contains a unique cart ID as well as an item map, which is a collection of item IDs mapped to the item quantity. So inside this item map, we have one item of ID 521 and 3 items of ID 923. Finally, the fact also contains the shipping method currently chosen for the shopping cart. On the other side, we have a delta event, item added to cart. Delta events detail the changes between one state and another. The contents of a delta event can vary quite widely, but typically includes information about the state change, including the reasons for the change. Delta events do not include information about data that hasn't changed. The name of the item added to cart event gives a pretty clear reason for its existence. The contents of the event include the cart ID, the item ID to be added, and the quantity of items added during that specific action. Now you may be wondering, why send all the data in a fact event if it hasn't changed? Why not simply send the delta? One of the biggest reasons for using fact events is due to its simplicity and effectiveness in transferring state. This pattern is known as event-carried state transfer, which is one of the best ways to asynchronously distribute immutable state to all consumers who need it. As a consumer, you do not have to build up the state yourself from multiple delta event types. This can be risky and error-prone, especially as data schemas evolve and change over time. Instead, you rely on the team that owns that section of that business to compute and produce a fully detailed fact event that acts as a data transfer object. While the shopping cart facts seem relatively simple, and it's plausible to compose the current state via delta events, let's consider a more complex scenario, where we want to build up the employee's annual tax return based on a number of forms, documents, and capital gains. If the tax team emits delta events for every single tax change, you'd end up with a vast amount of events detailing very complex changes. It would be very hard for you to piece all of these back together in the correct order with the correct business logic to obtain the total tax results. In contrast, if the team simply emits the completed tax results as a single tax fact, you can easily consume it into your system without having to compute anything on your end. Measurements from sensors and other Internet of Thing devices can also be represented as a stream of facts. Each measurement provides a complete picture of the state at that specific point in time. A weather sensor may indicate the temperature and pressure at a given point in time. Consumers use these events to derive temperature trends and to detect changing weather patterns. Fact events can be modeled to include both a full copy of the state before a change and a full copy of the state after a change has occurred. This model is commonly found with change data capture services, but can be made part of any fact-based event model. In this example, the cart fact shows what adding 3 new items to the item map may look like. You may also notice that the shipping selection was also updated, all in a single event. Before and after fields provide a complete picture of what data changed, providing consumers the ability to react to simple changes without having to store any local state. However, a major trade-off of this approach is that it effectively doubles the amount of data transmitted over the wire and incurs extra network, storage, and processing costs. We can also use fact events to infer a change, though it does require that we have 2 states to compare. In this case, the first fact contains just 1 item in the shopping cart. The second fact shows the addition of 3 more items, as well as changing the shipping to express. If the consumer wants to infer what changed from fact 1 to fact 2, they will need to maintain a copy of local state and infer the changes between these 2 facts themselves. While this does incur state maintenance costs, the consumer service has a full copy of each state and can infer any changes to any fields, providing them exceptional flexibility. There are a few things to consider though when creating event facts. First, the size of the event. Fact events could be an order of magnitude larger than delta events, especially if you decide to include both the before and after components. For certain data sets, the sheer size of data may make it untenable to contain within a single fact. Secondly, the frequency of change needs to be accounted for. A fact event that is updated very frequently will have very many instances created. If the event size is large, it could have a substantial impact on the producer, the event broker, and the consumers. If you decide to pack multiple changes into a single fact event, you'll need to consider if it remains timely enough for the business and the consumers to make use of. Finding the right balance can be challenging. Third, fact events can lose the intent. When we emit a fact, we're basically saying, here's the state of the object right now. But we do not communicate the business reason why that event occurred. While you can still infer what fields changed by comparing a new fact with a previous fact, the business why is not explicitly communicated. Fact events remain a very useful way to communicate the current state of affairs to your consumers. But you must ensure that you have a good understanding of these trade-offs and determine if they're acceptable to your use cases. And now we're going to look at the other main event type, the delta event. Delta events are defined as the changes that occur within a system, exposed as an event on the outside. One side shows a sequence of moves in a game of chess. These are delta events. Each move indicates the piece that moved, along with the source and destination location. In contrast, the total state of the board is shown on the other side with each subsequent move. This is synonymous with fact events. We have already introduced the item added to cart event. But what about another operation that we might do in the cart domain? This is a discount code event, produced whenever a user applies a discount code. This event is useful for other applications that want to react when a discount code is applied. But you'd be correct to guess that we'd also need a discount code removed event to indicate when that code is no longer in effect. Delta events are good at capturing the intent behind the creation of the event and provides context for the event's consumers. A cart fact models the portion of the cart state that we want to publicly expose to other consumer services in our organization. With delta modeling, we instead select specific state transitions and build a model that describes the change, not the state. Delta events are very well suited for exposing specific transitions in a system to downstream subscribers. Delta events provide a partial set of information that is usable for the consumers to act upon with their own business logic. Let's start by looking at how delta events are commonly used. Event sourcing is one of the main use cases for delta events, typically used for data on the inside. Instead of modifying state directly, you issue a change to an event stream. Then you take all of those changes and apply them in the same order they occurred to build up your current state, just like the chessboard example we just saw. Let's look at an event sourcing shopping cart example. On one side, we have a sequence of cart events detailing additions, removals, and eventually user checkouts shown in the descending order. The producer system creates the events and writes them to a Kafka topic. These events are then read and applied in the same order that they were written to build up the current state. The other side shows the current consumer state, built up by applying each of the delta events in the precise order that they were written. You should avoid sharing event sourcing events outside of your service, as they are heavily intertwined with the service's implementation details. Multiple independent consumers who want to obtain a current copy of the cart state would have to then compute it all on their own, duplicating cart building logic across multiple systems. Doing this is very risky for several reasons. The cart composition logic may change over time, requiring synchronized updates to multiple consumers. The consumer may fail to compute the cart state correctly, which may go unnoticed and cause difficult to track down errors. And the consumer application may fail to include an event type in their computations. This may be due to a human error, but may also be due to the creation of a new event type due to changing business requirements. While you can use delta events to build a subset or customized view of state unique to the downstream service, many consumers can simply rely on fact-based event-carried state transfer instead. Delta types still remain great for communicating when a change has occurred, but they're overall a poor choice for communicating the current state of a system. With fact events, the cart building logic is kept entirely within the producer service. It owns all of the logic for composing the cart, as well as the schema and the definitions of each field and value. If a consumer wants to know what's going on in a shopping cart, they simply listen to the fact events detailing the current state of the cart. All of the cart building logic lives inside of the single producer service. Now, it may be using event sourcing internally, but that is an implementation detail about what's going on inside its boundary. This is data on the inside. In contrast, the cart fact stream is published specifically as data on the outside. Consumers can infer their own deltas from the stream of facts by maintaining their own cache about the fields that they care about. Both facts and deltas can provide data to event stream consumers, but it's important that you explicitly think about the data leaving your system boundaries as data on the outside, separating it from the data on the inside. Your events act as data transfer objects that are purpose-built for transferring information to other teams and systems. While it's important to consider your consumers' use cases when creating facts and deltas, you should remain cautious about overly specific events and overly broad data models. Let's take a look at these two risks a bit more closely. The first risk is event model sprawl. This issue tends to arise more commonly with fact events, since they're supposed to detail the entire state of an entity at a point in time. Your consumers may request that you add more information to the fact, especially in the context of denormalizing data and joining it with data from other domains. In this sample dialog, we have a consumer requesting extra data about the total cost of items in the cart. It may be reasonably trivial to include the pricing information, especially since it's readily available when the item is added to the cart. However, it may be much more difficult to include other data, such as item-specific properties, inventory levels, and estimated shipping time, as these pieces of data are likely the responsibility of another service. In this case, our producer chose to expand the cart fact to include the cost of items, because that data is readily available and the request is easily fulfilled. Meanwhile, UPC codes, inventory levels, and estimated shipping times are not sources of data that the service deals with or owns. To obtain the data, we would need to query another service or ingest another event stream simply to do the work on behalf of the consumer. Instead, we reject this request and push the work back down to the consumer. As a general rule for event design, feel free to add any data that your service owns to the event, but be careful about adding in data that your service doesn't own or does not use. Another risk involves custom-triggered events, in most cases pertaining to delta events. While fact events may be triggered whenever a field in the event is updated, delta events are triggered whenever specific business logic conditions are met. For example, item added to cart is triggered when an item is added to the cart. However, you may run into consumers requesting custom notifications for when the conditions of increasingly complex scenarios are met. In this case, the requesting consumer wants to know when a sale item was added to the cart, but only if it's clothing and only if it's worth more than $50. There's a problem with this. On one side is the producer application, in the middle is an event stream of deltas, and on the other side is the consumer. These dotted lines represent the consumer-specific business logic. One option is to put the business logic into the producer application and use it to generate an event. However, this logic is entirely specific to the consumer's needs, but it does not live inside the consumer's codebase. It lives in the producer's code. Meanwhile, reactive business work lives entirely inside of the consumer's code. If the consumer wants to update the trigger logic at a later time, say that clothing must now cost $100 or more, then they must file a ticket to have the logic changed at the producer instead of simply changing the logic in their own application. This results in extremely tight coupling, where business logic is distributed amongst many systems and changes become very hard to make. Instead, put the consumer business logic where it belongs, inside the consumer. The consumer is solely responsible for building up their own state to evaluate the business logic, using either facts or deltas as they see fit. The consumer retains full control of their business logic, and the producer is not on the hook for producing any fine-grained events. One other question that we commonly get is it possible to build a fact event with some sort of reason as to why it was created? The answer to this is yes, and the event type is known as a composite event. It's helpful to think of these as both a combination of fact and delta. In this example, our cart fact includes an item added to cart reason. You can also create composites that have before and after fields. This composite is the same before and after event we saw earlier in this module, but now it contains a reason field as well. Your consumers can choose to react in different ways depending on the reason for the change. As an alternative, you can build your composite event as a delta with some state. This example shows an item added to cart delta that also contains the current cart state computed after the results of the event have been applied. This requires the producer to maintain a current model of the state, but reduces the need for consumers to build up their own state based on deltas. In practice, composite events aren't particularly common, but they can be useful on occasion and are a good option to keep in your toolkit. So far, we've looked at facts, deltas, and composites. But when do each work best, and when should we use one over the other? Overall, facts provide the best choice for sharing state between systems. The producer retains all of the complexity of building up any current state, while the consumer benefits from the simplicity of up-to-date state transfer without any computation on its own part. In contrast, delta events can provide hooks for consumers to react to certain conditions. Consumers remain responsible for inferring more complex deltas, though. While it can be possible to communicate state via deltas, it generally remains a better idea to use fact events for this purpose.